Give me a show of hands. How many people out there have some sort of a CI/CD? OK, great. You're in the right talk. How many of you are using a fully managed solution like Circle CI or Bitrise? OK. And how many of you think you're paying too much for this solution? That's what I thought. We, at BetClick, we've been burning money for years, paying for this fully managed CI/CD solution from Bitrise. And this year we said, enough is enough. We ditched our old solution, and we created an in-house CI/CD that saved us a bunch of money and also improved our build times. So this morning, Paul-Anatole and I are going to show you how we did that, showing you that it's not near as complicated as you might think, and that it is a viable option for your team to consider. At BetClick, we're a pretty large team. We have not only a native iOS application, but also we have a native Android application, and a website, and a web app written in Angular, or using Angular. On our iOS team alone, we have about 14 engineers, and Paul-Anatole here is our fearless leader. Say hello, Paul.
I'm like this creepy old dude hiding behind. Hello, guys.
But in actuality, he's the iOS engineer, architect, principal engineer. But more importantly for today, he's the guy who made this in-house solution. And speaking for myself and the rest of the iOS team, which is somewhere out here, there they are, we're really happy that he did. Let's start off by talking about the why. Why would we take a perfectly good, fully managed CI/CD solution and throw it in the garbage? Why would we do that? Well, this is why. Before 2021, we were paying about 7,000 euro per year on Bitrise. This was our iOS team and our Android team. For every PR, we would run our entire suite of unit tests. And every night around 2 a.m., we would run the entire suite of UI tests on our project. Every 2 weeks, we have a release train where we do all of this again, and also deploy things, all of our builds, to the store. So pretty normal workflow. But starting in 2021, things started to get fishy. Our price went up from 7,000 euros to 35 to 70, and then to a record-breaking 110,000 euros this year. When we saw that, we said, we can't continue like this. There has to be a better solution out there. So this pushed us to start looking for something better. And the first step in our search was to create a wish list. We needed to list out all of the things that we wanted in our new solution, some things that we had to have, and some things that would be nice to have as well. So starting with the list of things that were absolutely required. First off, cost control. Never again did we want to see a chart like I just showed you, where exponentially year over year it got more expensive. We wanted something predictable, something that we could actually budget for, and something, not as scary as that chart. That was very scary. Next, we wanted access to our CI/CD solution in 2 ways. First, with an API, and also with some sort of a nice user interface. Next, we have secrets. We have API keys, we have tokens. We want to make sure that what we're using is going to keep all of our sensitive information safe. Because I said that we had the iOS team, Android team, and web team, we want something not just for us, something that we could potentially add the Android team and the other teams to as well. Next is availability. If you haven't heard of availability, they use this term on the fully managed CI/CD solutions, saying that we guarantee when you want to run something that almost 100% of the time we have a machine ready for you, and the build will start immediately. And we got used to this. So in our new solution, we want something that is near 100% availability, so we don't have to wait to start our build. Next, we want third-party connectors. So we want to be able to connect to the Apple Store, the Google Play Store, the Teams, and Slack, you name it. We want to be able to connect to a bunch of outside services. And finally, for our industry, it's really important that we can audit who did what when it came to the CI/CD. So for us, we needed something that had reliable logs that legally we could look back on in case something went wrong. Now time for the bonus. In addition to this cost control, it would be better if we had better prices. It would be also cool if we had better build times, if it ran faster, if it was easier to do the binary signing, the cache management, and the maintenance. And finally, it would be great if we had some way to monitor the health of our CI/CD system as a whole, so we can more easily calculate our return on investment, but also detect if there's a problem really early on in the process. So now that we have this wish list, the requirements and the bonuses, Paul-Anatole is going to walk you through the next step of doing studies.
Before we start, we are going to build a new CI/CD. We need to understand what are the weaknesses and the strengths of the current one. And to do this, we need to understand how is it built. At Bitrise, they have done a tremendous job hiding all the instances behind the solutions from us. So we will need to rebuild it, and to do that, we need to understand what are those instances. The first one is the orchestrator, how your builds are going to be scheduled. It could be scheduled by UI, by API, or through your source code management by triggered. For example, if you have a pull request opened, you need to build something. If you want to launch a build from a command line, you should be able to do it. Back in those days, we all used something called Jenkins or Hudson. In those Jenkins solutions, this instance is called the Jenkins master. If you remember, you cannot set up crons on it to schedule builds. It was the Jenkins master. So we need to replace it. What we do with Bitrise is that we have these tremendous UI interfaces where you can just write, drag and drop from the interface, the crons, scheduled from the pull request. On this pull request, I want to do this job. It's very easy to set up. The first problem that we have here is that when you do this from the interface, you are deeply linking your project to your CI/CD solution. And this is the first mistake. Then what Bitrise does is it's going to pull up a machines for you that will execute your build script. The second instance that we have is the build script. In CI/CDs, which means continuous integration, continuous delivery, the build script is responsible for building, testing, and deploying your app, your website, your back office, your backend, you name it. In this case, we are going to focus on iOS and Android, and we will stick to the build script as the fast file. Okay? Once again, at Bitrise, they have done a tremendous job for keeping you from thinking about it. They have built top connector out of shell. You can just drag and drop it from the interface, and it will deploy your code to the App Store, to the Play Store, you name it. This is the second mistake. I'm going to ask you 2 questions. Who in the audience is using Match for code signing? Who is using drag and drop interface for certificate provisioning profile? You lazy bastards. You shouldn't do this because, once again, when you do this, you are strongly linked your SaaS solution to your project, and you shouldn't. Okay, so if we sum up from here, we have the orchestrator that will schedule the build. When a build is scheduled, it will execute your scripts, your build scripts. And the last part, the last piece of the puzzle is how are we going to set up the machines. So we need to build a scalable set of machines that will execute our build script. Okay? Because it's the toughest part of this presentation, I will focus a little bit on this. We use if you want to schedule builds, you will write some YAML code, it's easy. If you want to write fast file, it's Ruby, but it's easy. If you want to set up machines, you will have to do infrastructure as code, and it's a little bit more complex. So we have three solutions to do this. The first one is the SaaS solution. Bitrise is expensive, so we can replace it with Circle CI, CodeMagic, some SaaS solution that already exist in the market. It's fully managed, so you have great SLAs. It's easy to set up, but the cost is very expensive. It's not easy to debug sometimes, and the build time for us is not that good because it took, for a pull request, 42 minutes to build. The second solution that we study was to use what we call an hybrid solution. So we will use, as an orchestrator, Jenkins or GitHub Actions, and then we will rely on a Mac cloud to instantiate the machines. So you can do it on AWS or on Mac Stadium, every cloud that supports Macs. So it's very good because it's scalable. You can have as much as machines as you want. The build time is pretty good because we studied it and it took only 20 minutes, so we decreased by almost in the half. The problem is that the cost is not, it's better than the SaaS solutions, but it's not that good. And it's due to the fact that when you use Cloud Mac, there is something called reservation time. If you use a Mac for 1 minute on the cloud, you will pay it for 24 hours. So imagine that at noon, every developer on the team, the 50 developer on the team, will open a pull request. You will have to set up 50 instances of Macs for 20 minutes, but you will pay 15 instances of Macs for the 24 hours. So this is a problem for us. The last solution that we study is to have, as an orchestrator, once again, Jenkins and GitHub Action, but to rely on our own Mac mini farms. The build time will be very good because it's only 15 minutes. The cost will be very good because once you bought the Mac, you don't have to worry anymore. And the tricky part will be the setup and the maintenance. At Betclic, we have to choose this solution, and I'll show you how to set up it. So better build time, checked. As you've seen previously, the Bitrise architecture, the SaaS solution architecture is very complex. But if you look at the three instances that we described before, it becomes pretty easy. There is the orchestrator that will schedule your build. Each time you have a build in the queue, you will just pull up a Mac from the Mac farm and then execute your build script on it. Pretty easy. So we have made some colors on the different instances. So each time we are talking about the build script, it will be in red, Mac farm in yellow, and orchestrator in blue. Make your Fastlane great again. Add icons, have fun, make Either happy from yesterday. So we are going to focus on this part of the script, the architecture, the build script. What is Fastlane? For those who don't know, Fastlane is a set of scripts written in Ruby that helps you build, test, and deploy your application. You can write it in Ruby. You can also write it in Swift if you're not comfortable writing it in Ruby. But it's in beta for like a couple of years, so I think you should stick with Ruby. It's not that complex. And there is a lot of built-in lanes that will help you deploy your test flight, for instance. So I strongly advise you to use Fastlane in Ruby. And there is a lot of documentation very well written, so it's pretty good. The idea behind this is to become CI/CD agnostic. By putting all your logic into your fast file, you will decouple the execution to the build script. And this is the most important thing. You need to be able to switch from a CI/CD solution to another just like that. So what our machines are going to do is only check out the code and then execute a Fastlane script. It could be for store connection, to sign your binaries using match, to use danger, any linter, most of the time danger. If you have test result that you need to upload anywhere, you should do it into your fast file. If you want to notify that there is something going wrong or that your build is ready, you can use your fast file to do it. And if you want to update your Jira, you can do it also in your fast file. So third-party connector will be handled only in your fast file. This is the most important thing. And even if you stick to Bitrise, I strongly advise you to remove all the connectors that you use into the workflows that you are using to put it into your fast file. So let's see some code now. Because the fast file is the most important file in your CI/CD, you need to write some documentation around any lane that you are using. So we are going to focus on the lane that deploy your app to test flight. So first thing first, we need to describe what it does. Well, it's pretty easy, this one, so it's uploading the build to test flight. Then there is the options. Because at Betclic, we have like multiple targets, we need to specify which targets we want to upload to the test flight. So we need options to do this, because our lane is generic, so we need to pass some arguments. It could be environment, it could be project, you name it. In this case, we are uploading the app on the App Store, so the environment will always be prod. And then there is the secret. On your fast file, since you are going to connect to the App Store, you need to pass secrets to do this. So be careful, list all your secrets. It will be easier if you are using any orchestrator to know what secrets you need to pass to your fast file. Then it's pretty easy. So we are going to create a lane called deploy app store. Then validate that the option that we pass is OK. So we don't have any project that is unknown for us. And for all projects that we pass, we are going to do the match app store. So we are going to configure all the signing for the app store. Then build the project. Use this built-in lane called pilot to upload your binary to test flight. If you are using Crashlytics or Sentry or anything else for Crash, you may need to upload your decims to the solutions. And then, if everything went OK, we want to send a message on Teams telling us that, OK, your build has been deployed to test flight. You can now test it. If something goes wrong, I also want to be notified. So we are using Teams. Sorry. So we will send a message telling us that we need to check what happens if there is an issue. So binary signing, checked. Now, how are we going to set up the Mac? We are going to focus on the yellow instances, which is the Mac Miniform. So we are going to use a tool called Ansible. And Ansible is a script-based tool that will help you for doing software provisioning, configuration management, and application deployment. Basically, it's just YAML files. It's very easy to set up. You just have to learn how it works, and I will show you in those slides. So we need to do a list of things that we want to configure on our Mac. The first one, obviously, is the software and updates. We need to have Xcode because we want to build iOS. We need to have Java to build Android. We need to have Node for the web. And we have Brew for anything else. For example, if you want to have Phrase CLI for Daniela's localization, you can use it installing with Brew. So all the software needs to be, we need to list all the software required for our CI/CD. Next, there is the OS setup, because we don't want our Mac to go to sleep. We want our Mac to have the same configuration. So we are going to set the time zone, the local, so our UI tests always run in the same environment. If you need to set up some SSH key on the machine, it will be on the OS setup, stuff like that. And then there is the last part. We need to connect our Mac minis to the orchestrator, here GitHub Action. It's called a runner. So we need to register our Mac as a GitHub Action runner from GitHub Action. So there is different version. You need to set up the connection. It's pretty easy because they provide for us a lot of scripts, but you still have some work to do. So building iOS, Android, and JavaScript, checked. So at this point, we bought 20 Mac Minis, we set up them in a rack, we configure them with all the same account, fixed IP, and SSH login. And from them, we are going to need to deploy a configuration on those Mac. For that, there is a first important file, which is called the inventory file. Basically, it's just the representation of your rack into a file. It looks like this. It's very easy. So there is the Mac Mini 1 with the IP, blah, blah, blah. Mac Mini 2, blah, blah, blah. And from this point, we are not going to call them Mac Minis, but nodes. So at this point, you have all your nodes representing in your files. You also can create groups if you want to have, like, if you want to deploy a new version of Xcode, for instance, you want to test Xcode 15, you can create a beta group where you will be installing Xcode 15 only in that group, test it on your CI/CD, and then, if it's OK, you just deploy it everywhere. Then Ansible works with two main instances, which is the tasks and the playground. A task is a unitary task, like, for instance, the DevTools. You will have a unitary task for installing Xcode, updating Xcode, installing Java, stuff like that. You can have task file for setting the keychain, for instance. You can have a task file for the GitHub setup. You can have a task file for, obviously, register your Mac Mini as a GitHub action runner. And you can have as much as you want tasks in your project. And then you will have playbooks. Playbooks is just a list of tasks, okay? It keeps your code dry. You can have plenty of playbooks. For instance, you will have the first setup of the Mac, where you will be running a bunch of tasks. And then there is the playbook for updating Xcode. Then there is the playbook for anything else. Let's check some code, because it's very important for you to understand that it's not that complex. And we will see here how to install Xcode through Ansible. So as you can see, it's just YAML file. It's pretty easy. So the first thing, OK, I'm going to check if Xcode is already installed. If it's already installed, I don't need to install it. So I'm going to check if this path exists on the machines. If it exists, I will register it into a variable, for skipping any steps that I don't need to execute after. Then I'm just going to create the directory, the targeted directory, download Xcode with the Ansible built-in get URL. Basically, it's just a curl. But we are on a Mac, but you also can deploy Ansible on Mac, Linux, Windows. So this Ansible built-in get URL is relying on curl on macOS, but it could be anything else on other platform. Obviously, we are only going to do this if it's not already installed. Then we are going to unarchive the zip file that we get with just a shell script. Then move it to the right location. Because Xcode is a little bit painful, we need to accept for the first time the license. We can do it with Ansible. It's only a command line. Then we need to validate Xcode, another step. And then we will do what we call Xcode select to select the right version. Don't forget that you can have plenty of Xcode version on your Mac. And as I previously said, if you want to install Xcode 15 for testing, you don't want to remove Xcode 14 unless you are sure that all your builds are running good on the Xcode 15. So for the start, you will just Xcode select on Xcode 15, check that everything is OK. If it's OK, you will run a playbook called delete all the Xcode version. And if it's not, you will just call a playbook called Xcode select Xcode 14 again. So to sum up, Ansible is pretty simple. You have an inventory file and the playbooks, and you will just run a playbook on an inventory. And a playbook is just a list of tasks. But there is one more thing. Because you are going to manipulate a lot of sensitive data, like passwords, SSH key, stuff like that. There is also a vault system on Ansible that uses asymmetric encryption that is pretty awesome and that will secure all your data for you. So this is Ansible. It will help you set up your Macs and ease the maintenance for you. Back to you, Robin.
Yes, thank you. Okay, so the last piece of our puzzle is all about GitHub Actions. If we look back at our architecture diagram, we've already gone over the first two big chunks here. We talked about Fastlane over on the build script, and we talked about the Mac Mini farm. So, do you hear that too? Okay. I think they muted themselves. Okay, so where were we? So we talked about the build script, talked about the Mac Mini farm with Ansible. Now we have this last chunk, the orchestrator with GitHub. And by orchestrator, Paul said before, this is where we say what we want to run and when we want to run it. We have an added bonus here because we have our source code in GitHub, and we chose GitHub Actions, so our orchestrator and our code are in the same place. So this removes any need to add another party into our architecture diagram, like Jenkins, for example. We have everything we need in one place. The first concept that you'll hear a lot with GitHub Actions is workflows. And it's nothing too complicated. A workflow is a series of steps. So if we take an example of a workflow, step 1 could be to check out the code. Step 2, you build the project. Step 3, you run the unit tests with as many steps as you want, all contained in a workflow. And you can have multiple workflows as well. These workflows are triggered, so they're told to start in a few different ways. The first type of trigger that we have is a trigger from the API. So you can run a command line and launch a build, for example, via a workflow. This meets the criteria we were looking for to have API access to our CI/CD solution, so that's looking good. The next trigger type that we have is a cron job, or a scheduled job. So in practice, this may mean at 2 a.m. every morning, we run the entire suite of UI tests while no one's logged on. GitHub does offer a set of on-event triggers. So these are highly integrated into GitHub. An event may be the creation of a PR. It may be the merging of a branch. They have a whole list of things. But today we're going to talk a lot about the pull request being our trigger. The last trigger we have, this one is kind of special. It's a trigger that can only be called by other triggers. So this is a tool that we can use to help keep our code really dry, to reuse workflows, because we can have 2 entry points to do the same thing. Let's say at 2 a.m. I said we run the entire suite of UI tests, but I also make a fresh build and deploy it to test flight from our develop branch, just to keep getting a current build every day. But it's Friday, maybe Friday at noon, my boss says, I want an even newer build. Can you make me one on test flight? So the cron job is the trigger that's scheduled at 2 a.m. But me, at noon on a Friday, I'm going to have to use the API trigger to launch the same thing. And we don't have to repeat the same logic behind. We can share. A few more things to know about GitHub Actions. They handle inputs really well. So like I said, we can share these workflows among the triggers. Each workflow can have inputs. So you can specify for the same workflow, you can change the environment or change the project even, so you can have even more reusability. And what's even better, once you specify what types of inputs and what the default values are, these get taken in automatically to the UI view in GitHub Actions, so you can have cool little drop-downs, specify all of your parameters manually from the UI, and launch something from there as well. Next, GitHub does manage concurrency. So on the trigger, when a pull request is created or updated, if I make 3 updates, like super quick, we can say cancel the 2 oldest, don't waste the processing time, just let the newest one continue and finish. So that's really good. Next, it does have a property called runs on. So here you can specify a few different things. We only run on Macs, but you can later, like our Android and web team, maybe one day they'll want to run on Windows or Linux or something. The matrix is also another cool feature of GitHub Actions. We have a list of 5 environments that we can run our app on, and let's say we have a list of 5 projects. Instead of writing out the command line for, OK, environment 1 with project 1, environment 1 with project 2, and all of the possible combinations, you can just give GitHub Actions those 2 lists, and it will cross them all. It will make all the combinations for you, so it makes things easier for us. Finally, GitHub Actions does have a way to manage secrets, so you don't have to worry about having any tokens or API keys being leaked. So going back to our wish list, this was something that was required for us. Now, if we look at an example here, we have our workflow, validate pull request. It's triggered when we create our pull request, natural. Inside our workflow, first step, you check out the code. We want to run our danger script to make sure nothing is horribly wrong. Then we want to build the project and run all of our unit tests. The way that we set up all of these steps, it's again with a YAML file. And this YAML file is actually in our project, so we can access if we want to modify these steps, add or delete. It's really easy for us to maintain and get to. So this YAML file, it's called validate pull request. On line 1, we give it our name. Line 2, we say what trigger we want to start this workflow. So here it's pull request. Then we get into concurrency. And here you can specify if you want that behavior like I talked about, where you make 3 updates to your pull request, and you want the older ones to be canceled automatically, which is what we want here. Then in the jobs section, you get into a few more parameters, where we can talk about the runs on. So here we say we do want to run on Mac OS. And as an example, we only want to run on the Mac Minis that have Xcode 15 installed. So you can have a difference here if you want to run something on Xcode 14 or something on Xcode 15, as you want. Finally, we do have a timeout. So if something goes wrong, we can just cancel the build automatically so it doesn't just keep eating up processing time. This next section, we're going to continue down into the steps. And the first step I mentioned before is to check out the code. But I'm going to skip over that here and get on to the second step, which is a little bit more interesting. The second step is called Fastlane Validate Pull Request, because we're validating a pull request. But this step, all it does is passes the ball to our fast file. It's very, very simple. So here we want to run a command. We're calling this shell script Fastlane here, and we specify the name of the lane that we want to use. And so this workflow, all it does is check out the code and throw the ball to Fastlane, where we have all of our logic. And what else? Yes, we pass it also the environment parameters here. So we can pass it whatever tokens, the name of the branch, whatever it's going to need to finish the lane. So if we look back at the example I just showed you, we had these 4 steps in our workflow, but because our workflow is actually just handing off to Fastlane, it looks more like this. So these YAML files that you use to manage your workflows are going to be very light, are going to be very easy, and everything is going to be very centralized in your fast file. Now, if we think of ourselves, the engineers, as the customers in this scenario, what does this entire flow look like from end to end? For the example of the validate pull request, I open a PR. Okay. This is going to trigger one of my workflows on GitHub Actions. GitHub Actions is going to start up a Mac. It's going to pick one of our Mac Minis that's in our farm. And then the Mac, in combination with the fast file, is going to run our danger script. It's going to build our code, run all of the tests, and then take those results and send it back to GitHub Actions, who will post that on my PR, and I will either see an error or I will see everything is green and I can continue on my way. To show you, I really want to zoom in on this one step, this update PR status here, because I find it really cool on GitHub. It's so well integrated. Because say I have my PR, and here we're running validate pull request, and we're also running the danger script below. Directly on my PR, it'll tell me everything went well, you're good. The danger script, that passed as well, so you can rebase and merge, and today's a lovely day. If things didn't go well, it'll tell you right away that, okay, validate pull request, this workflow failed. And if I want to see the details for why, this button over here on the right will bring me directly to a summary view that I can customize. And here, we wanted to see immediately on this bottom part in white which unit tests failed. So I have 3 that failed that I can go and look at immediately. If I need more detail, we also added in this link to see the test results, this artifacts URL there. And you can add a lot more if you want to have more details or different details for your summary when the workflow fails. Finally, I mentioned we have this danger script. So on our PR, again, directly, you have this persona of GitHub Actions, and it'll tell you if you violated a rule in the danger script. So very quickly, you understand that, okay, I didn't squash all of my commits on this PR, and that's a no-no. So I know immediately what I need to fix. I can fix it. I don't have to dig around somewhere to figure out what went wrong. Now, at this point, we've talked about all 3 parts of our architecture, and everything's working together swimmingly. But you may be wondering, did we accomplish what we set out to accomplish? And the short answer is yes. If we start by talking about our build times are faster. Here, I took a random sampling of our validate pull request workflow over the past month. It's not very scientific, but to give a good example here, this includes our wait time, our queue time waiting for a Mac Mini, as well as the build time for the actual workflow. So it's a little bit inflated. It's not showing just the workflow times. Our target, when we said we wanted to do this self-hosted solution, was about 15 minutes. And here you can see it's more like about 19 minutes. We're pretty sure to have it all done. But considering it's the queue time and the build time, I consider this a win. Now, I said this wasn't too scientific, my chart here, but we also get very scientific with our data analysis. We have a logging tool called Datadog, and some of you may be using it or something similar. Datadog has an easy connection into GitHub, and so it can take all of these statistics that you have about GitHub Actions, about your workflows and build times, and it even has some pre-made dashboards, so you can get really scientific charts and in real time showing you if there's a problem on the CI/CD, or you can use it to get data to calculate the return on investment, like I said before. So build time, check. We're satisfied. Now in terms of cost. Here, again, is the scary diagram I showed you at the beginning. So we had a little bit of startup costs. Mac Minis are not cheap. So in this first year, in 2023, we bought 20 Mac Minis. And what did we do? That cost about $30K, just about. And then we had a little bit of setup costs to configure this entire system from scratch, so that did take some time. Brought us to about $50K for a price tag this year. It's a lot, but for the next few years, the cost of maintenance and a small refresh of Mac Minis here and there is very, very cheap. We're back down to an estimated 10,000 euros per year, which is very similar to what we were seeing before 2021. So for us, the cost, we nailed it. We're very happy with this result. And the last way we can look at the results is to refer back to our wish list that we had at the beginning. Did we meet all of our expectations? Oh, there we go. So cost control, check. So the wish list. We got pretty much everything on our wish list. We got the cost control, like you just saw. We got the access via API user interface. Our secrets are managed on everything that we use. We can support iOS, Android, and JavaScript. Availability is kind of there. We're in flux right now because we had really good availability. We had almost zero wait time when we first started. It was only our iOS team using these Mac Minis that we bought. But we added the Android team. So we had a little bit of wait time because they had their builds too. And then we added the web team. And now we have a few minutes of wait time getting on those Mac Minis with all of us on the same. So over the next few months, the availability is going to be great. We're just trying to feel out that happy medium between how many builds we have on all three teams and how many Mac Minis we actually need to support those. So in the next few months, that will be a green check mark for us. Finally, we have the third-party connectors like you saw, and it is a system that is auditable. For the nice-to-haves, we actually got all those too. Cheaper, better build times, our signing, cache management, and maintenance all ended up being easier. And we have the CI/CD monitoring through the Datadog connection that I talked about. And I'll pass this back off to Paul for the next section.
Thank you. So at this point, if you remember correctly, we have our three instances that work within each other, and it worked perfectly. But there is things that we haven't cracked yet. And the first one is the job priority on GitHub Action, because it doesn't exist yet. So we are going to take a use case here. Imagine that there is a PR on the web app, and then a PR on iOS, and then on Android, and then back on iOS. The problem is that in GitHub Action, it is a FIFO, first in, first out. So the second problem is that when the web app builds, it will split the job into 100 jobs of 2 minutes. So it will need 100 max to run for 10 minutes, because it will be batch of 20 max. So during this time, all our builds are going to be queued. So on iOS, it took 17 minutes to build, on Android 12 minutes. So if we use this solution, we will have our build ready in 10 minutes in the web app, and then when all the runners are going to be free in 10 minutes, we can run our iOS PR, so 10 plus 17 minutes. Android, same thing. They are going to have to wait for the web app to finish, and same thing for our second PR. If we could just add some priority on the jobs, we could run a first batch of 20 Mac Minis for the web app, and then see that there is higher priority jobs in the queue, and then runs automatically those jobs, so the iOS and the two iOS and the Android, and the result will be better, because on the web app, you will just have to do not 5 batch, but 6 batch of 2 minutes, so it will be 12 minutes, and on iOS and Android, it will be only an addition of 2 minutes, so it will be quite better. But this priority doesn't exist on GitHub Action. There are some people that are talking about it on their repository, but I strongly advise you to put some ratings on it so we can have it soon enough. It's not on the roadmap yet, I checked, but I hope they heard my talk and put it rapidly in the roadmap. Then I will give you a quick advice that mistake we have done and you could avoid if you do your own solutions. The first one is that at Betclic we are using SPM, as Christopher mentioned it yesterday. We respect the pattern, but we use private package. And the problem is that when you use GitHub Action as an orchestrator, it will give you a token to check out your project, and this token is only related to your repository. So if you have private repository, sorry, it will not be able to check out those repository because the token has not access to it. So what you can do here is, instead of using the GitHub token that they provide, you can set up with Ansible a SSH key that gives you access to all the repository that you need to, with Ansible on the Mac Minis, and then instead of using the checkout classic on the GitHub steps, you will just use the GitHub with SSH. If you want to see what we need to do in Ansible to set up a SSH key, because it took us quite some time, first you need to create a git config file, whitelisting the host. Then you will have to kill all the SSH agent on the Mac, whitelist all the IP from GitHub, add it to your known hosts, then relaunch your SSH agent, and then add the SSH key, sorry, that you have passed through Ansible to your keychain. Basically, it took us hours because we didn't know anything about keychain, SSH key, stuff like that. But once we cracked it, it worked very well. And if you want, we can share the code, the Ansible code that do this, if you're interested. Next one, out of space. So as Robin mentioned it before. First, on the Mac, the only build was iOS, and then came Android, and then the web app. So the tools that we set up on the Macs, instead of being just Xcode, because we can have plenty, it's Java, it's Node, and then we have the cache from Xcode, but then the cache from Android, and then the cache from the web app, and then we have the artifact that we didn't delete on iOS, on the web app, on Android. So after 2 weeks of running, our Macs was out of space because we took the cheaper one, the M1, but the cheapest. So we didn't have any space. So what we have done is that in our GitHub Action steps, we just call a script that will clean the disk if needed. So basically, it will go to the machine, evaluate the disk space, and if it's below 10% of free disk space, it will clean some cache, remove the artifact that we store, clean the derived data, stuff like that. And it worked well since we have this. So clean this space. OK. As you can see, it was // so the script today is in our iOS project, but it's also on the Android project and on the web app project. The idea is to move this script on the Ansible part, so we can share it between the whole platform and just call it from the GitHub Action as we do, but with the same, we all have the same script. Because if the web app wants to add some cache delete on their script, they need to make a pull request on our GitHub repo and on the Android one. So it's not easy. Last one is the zombie file. So for some reason, sometimes when we check out the project, it struggles deleting some log file. So it doesn't build anymore. We don't know why, but there is this log file that stays in our project. So what we do is just, on our GitHub steps, we just add a remove zombie file, which basically is going to remove our submodule log file, and it just works fine. It's not beautiful. It's a little bit dirty, but it works, and sometimes you have to make compromise. OK. Animation. Yeah. I cannot resist asking ChatGPT about how to build a CI/CD. So I asked him, hello, Jude, can you build me a CI/CD? In fact, it was a little bit more complex. I asked ChatGPT to build a native CI/CD for iOS with my own Mac Minis. That was the full question. So because we have a good relationship, no problem, mate. First one is select a CI/CD solution. So I was like, OK, I have GitHub Action. OK, all right, set up the Macs. All right. What do you mean by that? Install Xcode tools, stuff like that. OK, no other clue that install Xcode. You need install Xcode, command line tools, because it's a little bit node response because you cannot install Xcode if you don't have command line tools. But anyway, and then the response from ChatGPT was quite good. It was set up your version control, create your build script, configure your CI/CD, so the trigger part, test with deployment, and then monitoring and notification. So he thinks about Datadog and monitoring. It's quite good. And then about security, avoid hard-coding sensitive data in your script. I don't know if that's the tone from ChatGPT, but I was more like, don't do stupid shit with your sensitive data in your script. But it was avoid hard coding, so use environment variables or secure storage mechanism. So that's quite good. And then, last question, I was like, okay, agent management, maintain your mic, build, agent, update, okay, all the Xcode version, stuff like that. And I was like, okay, can I use some tools like Ansible to do it? And then he started to talking nonsense because he was like, oh yeah, you have to brew install and then brew update and then brew install. And okay, stop. I stopped the question here. It was fun. What's remarkable with ChatGPT is that the answer, the step that they provide for us was quite good. So it could be a good start. The wrap-up?
Yes. Thank you. So we gave you guys a lot of information today. You saw at the beginning how the increasing prices, the exponentially increasing prices, drove us to search for a new solution for our CI/CD. You saw the 3 parts of our architecture, how we set up the Macs with Ansible, how we used Fastlane for our logic, and how we performed the orchestration with GitHub Actions. You saw our results and how we saved... I missed it. But you saw our results for how we saved money and how we had faster build times and how we met all of the criteria except for the availability on our checklist. So we hope that this has shown you that it's not as complicated as you might have thought in the beginning, and we hope you go back and tell your teams that, okay, this is an option if we want to lower costs. So thank you so much for your time and attention, and now we're ready for questions.
So I have a question from Anonymous once again. He's here, or she's here. What is behind the approximate 10K euros per year?
Okay, it's the maintenance of the Mac Minis because we have to update Xcode sometimes, we have to restart the runner, sometimes we want to make updates on it. So we provided 10 grand to do this. And also we have the Mac Minis in like 3-4 years. We will probably want to renew the Macs. So it's in the 10K. So 5 for the Mac Minis, 5 for the maintenance.
Okay. How do you manage automatic OS updates?
That's a good question.
From Anthony, thank you.
At Betclic, we use MDM, so device management. I don't know the first M, but
mobile.
But it's for the Mac. For all basically, our
Mac
computers are under watching by the IT workplace. So we have a tool called Jump. And the Mac Minis are handled by Jump. So when I want an update on the Mac Mini, on the OS, I just ask Jump to do it for me, and it will automatically update the OS version with the one I want. But yeah, we didn't talk about that because it's very linked to Betclic. It's not related to your project.
Thank you. Where do you host the Mac Minis?
It's in Iraq. We have server rooms. We have 2 server rooms, one in Bordeaux, where we work, and the other one that we are going to create, because we bought 20 more Macs, are going to be in Malta, because we also have an office here and a server room.
Did you already have security issues?
Did we have security issues?
Did you already have one?
Have we been hacked?
Yes, that's another way of putting it.
Not that I know, but maybe I need to check the max for. No, because we are in the server room at Betclic, it's encapsulated into our own environment, so it's pretty secure by design. But so we don't have anything right now.
About cost control for future years, did you take into account the fact that the question is really long? Sorry.
The Mac Mini are gonna die.
Yes.
That's sad.
Yeah, a Mac Mini cost 700 euros, I guess. So it's not that expensive. When you saw the 50Ks for the setup, it was 30K for the Mac Minis, and the other part was for the setup. So it's only 30K, considering the fact that we were paying 100K only for mobile. But the web app also has cost. And before going to our solution, they were using Jenkins on the cloud with UC2 instances on the cloud, and it cost us 50K per year. So when the Mac will die, we will buy a new one with a lot of disk space this time.
Thank you. Question from Zino. Maybe you know this guy.
Yeah.
Why not go full self-hosted and use something like GitLab on premises?
Because we already have GitHub on the whole company, so it was. That's a very good question because we don't speak about that. We don't want to have. We want to be the more reliable as we can. So if we add, that's why we didn't choose Jenkins, for instance. If we have another Jenkins, it will add a connection between Jenkins and GitHub. Then, so it will be GitHub Jenkins, Jenkins the Mac, the script, GitHub. With GitHub and GitHub Action, you only have one connection with the Mac, then the script back to GitHub Action. So we choose GitHub Action because we were using GitHub, and the less instance you have, the more reliable you are.
A more nowadays question: do you think this solution is usable with a fully remote team?
Yeah, why not?
I'm not the one asking. It's anonymous once again.
Well, someone has to have room in their closet for the Mac Mini farm.
Exactly.
But if you have that, then fully remote.
That's the only issue. We'll take one final question. How do you manage Mac Mini disk storage?
We don't. So as I explained, we have this script that will free disk space if needed. And also on Ansible, we have a task where we playbook, a running task that clean the unused tool from the Mac. So as I said, the Macs come with Jump. Jump will install Teams on the Mac, Office 365. So we have the tools to remove all these unnecessary apps. And when the Xcode feature, Xcode simulator is not in use anymore, we delete it with Ansible too.
Perfect. Thank you.
Cool. Thanks.